We on Earth are exceptionally lucky, while we are very rarely conscious of it. We exist and are alive today because Earth has an oxygen-rich atmosphere that we are breathing right now. And not only that, but the atmosphere provides safety from the cruel environment of space. I'm Alex McCone and you're watching Astram, and today I will unravel the different layers of Earth's atmosphere and explain how they are so important to our existence. If I were to ask you where Earth's atmosphere is, I think most people would quite confidently say it was all in this area here. Surprisingly, this is not actually the case. This video was taken on the ISS, which orbits Earth at 340 kilometers. Let's start right at the base layer, the one we are most familiar with because we live in it. The troposphere. At only 20 kilometers high at the equator, it's the thinnest of all atmospheric layers. The defining thing about the troposphere is that the higher you go, the colder it gets. From my own experience living in Switzerland, this can be seen when it's 20 degrees at the base of a mountain, but at the top it's still snow-capped. This temperature disparity is due to how heat energy is transferred through conduction, convection, and radiation. The atmosphere is not as good at absorbing solar energy, and most light passes straight through. But interestingly, the atmosphere does interact with some wavelengths of light, particularly blue wavelengths. This is called Rayleigh scattering. This process of convection happens on a grand scale near the equator and explains why the troposphere is higher there. These are called Hadley cells, and similar cells exist at mid-latitudes and polar regions. These cells are the cause of trade winds, tropical rain belts, hurricanes, subtropical deserts, and jet streams. Above the troposphere is the stratosphere. Commercial airlines prefer to fly here where possible as they can avoid most weather disturbances. The stratosphere contains the ozone layer, 3 oxygen atoms combined into one molecule. It absorbs dangerous UV light before it reaches us on the ground, even though ozone concentration is only about 10 parts per million. Felix Baumgartner's world record skydiving jump was performed at roughly 39 kilometers, still well within the stratosphere. After the stratosphere comes the mesosphere, where we find the coldest places on Earth at minus 143 degrees Celsius. Here we can see noctilucent clouds, the highest type of cloud found on Earth, between 76 to 85 kilometers up. The thermosphere can reach temperatures of 2,000 degrees, though it would still feel below zero due to low air pressure. High-energy waves from the sun are absorbed here, creating the beautiful aurora we see in the sky. On Earth, there exists a powerful icy force to the north seeking to rush southward. That winter is kept at bay by a mighty wall, the polar night jet, which protects us from the polar vortex. The polar vortex is a massive cyclone sitting over each pole, spinning with wind speeds that can reach up to 240 kilometers per hour. But sometimes the polar night jet breaks down. In the US, the 2019 polar vortex saw temperatures as low as minus 50 degrees Celsius, leading to 22 deaths. When the jet stream buckles and pivots, regions like Europe and America suddenly find themselves in the domain of the polar vortex. The forces of winter have arrived. Above our planet's poles, an invisible force is at work. Recent breakthroughs from NASA's Endurance mission have finally measured the ambipolar field, a force as fundamental as gravity or magnetic fields. This global energy field is responsible for sculpting our atmosphere and driving charged particles into space. Around 90 kilometers above Earth's surface, plasma forms from ionized particles trapped along magnetic field lines. In the 1960s, spacecraft detected a supersonic wind of charged particles flowing out to space. Many were cold with no signs of heating, yet traveling at supersonic speeds, leading to the discovery of this third energy field. The ambipolar field, like our magnetic and gravitational fields, is a critical feature that helps make our planet habitable. It's remarkable how much invisible protection surrounds us, shaping the very air we breathe and the climate we depend on. Thanks for joining me on this journey through Earth's atmospheric layers. Until next time, keep looking up.